One of the hardest things in robotic simulation is really the physics engine, and especially when we're trying to do things like soft body deformables, when we're trying to do things that are dexterous grasping. These are things that are a little bit beyond what we had built PhysX for. Newton allows us to bring it under a single API, a single interface, and so that way you can take these different solvers that various teams are working on and then couple them together into a single simulation. Maybe we want to start doing some physics. There's the Newton viewer, which allows us to view what's happening inside of the simulation at any given time. Cloth twisting especially. The other types of workloads that are really going to become important in the future are going to be cabling. And cabling is pretty much any type of linear deformable. And so you can imagine it being the threads inside of elastic suits. You're going to have things like power cables, Ethernet cables, copper cabling going inside of cars. And so this is one of the most asked for use cases because it's used heavily in production, especially in industrial manufacturing, whether it's cars, airplanes, our general electronics and facilities. And so what we're trying to do is bring this to life and give developers the opportunity to have a single unified interface, bring it all together, make sure they have interop between all of their tool sets. And so when you're using Newton, because it's open source, it's freely available, you can leverage it by using MJ Warp, for instance. And then if you're doing work in MJ Warp and you want to transition over to ISOLAB, it makes it that much easier. And so this removes a lot of the friction that causes researchers and developers to be spending upwards of 1 or 2 months trying to move all of their scaffolding over. And so now this becomes relatively ubiquitous.